Okay, we look at converting an equation from rectangular form to polar form. What that means is we need to take things that are in terms of x and y, rectangular form, and convert them to polar form, which means replace every x and y with something involving r and theta. Well, one thing we know is that excuse me, r squared is x squared plus y squared. So if I ever see an x squared plus a y squared, I can replace it with r squared. Similarly, x is r times the cosine of theta. So if I see x, I can replace it with r cosine theta, or if I see y, I can replace it with r sine theta. Okay, so those are the conversions that we will be using to make these conversions from rectangular form to polar form. The equation y equals 5 is in rectangular form because it has y. To convert it to polar form is very simple. Y is the same thing as r times the sine of theta. And now it's in polar form because it's got just r's and thetas and no x's or y's. Another one, x squared plus y squared equals 7, is very simple because x squared plus y squared is r squared. So r squared equals 7 would be the equation in this case. X squared minus y squared equals 1. You can't use the formula x squared plus y squared is r squared because this is x squared minus y squared. So instead, let's replace x with r cosine theta, and let's replace y with r sine theta, and then square each of them. Now realistically, you could stop right here because you have r's and thetas and that's what we're looking for, but you could go further. For example, if you square the first one, you get r squared cosine squared theta minus r squared sine squared theta equals 1. And if you wanted to, you could factor out the r squared, and you'd have cosine squared theta minus sine squared theta equals 1. And you could use some trig identities, all kinds of things, but the point is any of these would be acceptable when you're converting to polar form.